All right, binary search. So yeah, this is a very common interview question on how to essentially search through what you're doing instead of starting from like index 0 or the last index and loop, or like essentially doing a for loop or a while loop all the way through until you find an answer or find the index or find the element that you're wanting to, because that's not a very optimal way to solve something. Because say you have an array that's 1,000,000 lines long, or it has a length of 1,000,000 and it's a sorted array. Like if you think about like the amount of data some of these companies have, like if you want to search through whether it's a database or just a list and try to find that. So if you have to search through a list that's 1,000,000 lines long and you don't know specifically what element or the element you're looking for is, 500,000, like having to start at index 0 and going all the way to index 5,000 or 500,000, it would take a long time. So what binary search and what recursion helps us do is to break down that problem into smaller and smaller chunks until we find what we're looking for. So am I recording? Yep. Let's fork this. So fork. So I'm going to fork it over to Tom's GitHub, and then I'm going to clone it down once it's done forking. So now I'm in Tom Preet's binary search, click the green code button, copy it to my clipboard. And so right now I'm in recursion. I don't want to be in this specific directory. So I'm going to move up 2 levels into November challenges. I'm going to git clone, paste that link in there. So Tom Preet binary search. Now, if I list everything out, I can see the binary search directory. I'm going to cd into binary search. I'm going to list everything out, and I'm going to code --r and open this challenge into a new VS Code window. So I'm going to use Python again, just because I want everyone to get comfortable with Python. We're going to be using this going forward. So let's just look at the README again. So let's take a look at some code. So in this random sample, it creates a list that looks like it's 10,000. Yeah, now we have a sorted list of 10,000 unique values between 1 and 10,000. So in binary search, we want to pass in our target number that we're looking for and a list of a sorted list. And so returns an index of 537 in values if it exists. Otherwise, just return -1 if it doesn't exist. So I'm just going to copy this, the premise of the algorithm. Again, we don't want to just immediately jump into the coding. Comment this out. So say you're searching for a number defined in a search set of sorted values. So finding a number in a sorted list. What we want to do is find the middle value in the sorted list. We'll call middle value. And if the number is equal to that middle value, then we've actually found our target number. Good. We don't have to do anything else. We're done. If the number defined is less than the middle value, we want to split that sorted array into 2 halves. So left and right, and we want to split it at the the middle value. And we want to split it. So if it's less than, we want to split it. And then we want to take the array on the left and pass it back into our algorithm. And it just keeps on doing that. If the number defined is greater than the middle value, again, we want to split the array into 2 halves. And instead of passing the smaller half of the array, we want to pass in the larger half of the array. But there is a little gotcha there, is that what we want to do is find the index of that value. And if we're passing in the larger array, we still want to store an index value as well, because we want to keep track of an index. like a tracker index. So, and then repeat until you find the number, or return 1 if it doesn't exist. So let's just write some pseudocode. All right. So the first thing I'm going to do is create a method, a method called binary search, and I'm going to capitalize elements in my pseudocode that I'm going to use, such as variables. So here's a binary search, which I'm going to be using. So create a method called binary search that takes in a target number, a sorted array, and we'll need to pass in another parameter, another argument, which is called like a tracker index. So, and a tracker index. And we can actually set this tracker index to an initial value of 0. So I'm just going to say 0. So it takes in 3 arguments: our target number, a sorted array, and a tracker index. And we want our tracker index to be set at 0, just because that's where because we want to append to or add to our tracker index, and we don't want to start it at 0. So the first thing we need to do, our pseudocode is practically here. So we'll need to find the middle index and round down, because what if the array is of odd values or has a length that's odd? So if you have 9, an array or a list that's a length of 9, you find the middle index, it'd be 4.5, but then you actually want to round down to have like the middle index be 4. Round down if necessary. All right, and we can do that. Let's see. Need to find the middle index, and we'll actually assign middle index to variable middle index. Cool. So next we'll want to do is find the middle number in the sorted array. So find, whoops. Oh, what happened? Let me bring something else up. Should look at my notes real quick. So yeah, we'll want to find the middle number in the sorted array. So we can actually say like sorted array. And how we do that is kind of just like sorted array and passing in like the middle index. This is just for reference right now. And now we can jump into all of our if statements, like if the middle number, do I even have the middle number? Middle number equals the target number then we'll want to add our tracker index to the middle index. So then I'm just going to do that. Add tracker index plus the middle index. And the reason why I want to do that, because if we're gonna be keeping track of this tracker index, and say it's like 5, and this tracker index is explicitly only for when we're using the right half of the array. So where the array is larger than our target number. Then we can say like if the target number is greater than the middle number, we can do something else. We can return the sorted array, but have it split in half. So return the smaller or right array, and then return the smaller array and pass it into the binary search algorithm again, or a function, but with our target number, same target number we're looking for, and the right or like the smaller array. So we need to actually split that. And then also just the tracker index plus middle index. Wait, is a smaller? Oh, so this is where it's greater than. Okay. Then pretty much we want to repeat the same thing. But if it's smaller than the middle number, return larger turn the right array, so larger. This is where this if statement is where we want to turn the larger array if it's greater than the middle. Oh wait, hold on, no, I have that backwards. Right? So if the target number is greater than, we want to return the left, or yeah, the smaller array. And if that's the case, we can just return the tracker index. I think. If the target number is smaller than the middle number, hold on a second. If the target number is greater, see, I'm already confusing myself. If the target number,
if it's greater, you want to add.
Yes, thank you. So, yep. So if the target number is greater than the middle number, okay, I was getting confused with that middle number. So we're going to want to return the larger index, or the larger array, which is the right array. I'm going to get rid of these larger and right. I just know the right array is larger. Left array and left array. Let's pass in the binary search target number, left array, and here we don't need to pass it in the track or the middle. We don't need to add the middle index to our tracker index. So for example, if we have should I create so if this is an example of our array that we're using, we don't really care about these values, just say this is a sorted array, but we want to look at 7. We have to find, so our initial tracker index is 0. Equals 0. And the first thing we want to do is split this array into 2 values. So is it 1, 2, 3, 4, 4? So yeah, so we want to do, it's just a visual. Okay. Oh, 1, 2, 3, 4. And so if our tracker index, so right now, if 7 is greater than whatever this would be, we want to look in this array. So it's 0, 1, 2, 3, 4, 5. So our new tracker index equals 5. And now we want to pass this part into our binary search again. So we want to split that, and it would be 7, 0. And it doesn't really matter what these values are.
Oh,
Oh, yep.
can I ask a question?
Yeah.
This tracker index, tracker underscore IDX, how does it know to set itself to 5?
Because we add, so it's through the middle number. The middle index is where we'll add it to here. So like the middle index, 0, 1, 2, 3, 4. So what's the length of this? 1, 2. So it's 5, 6, 7, 8, 9. So yeah, I guess right here, this would be 4 then. I stand corrected. So it's the middle index of the array that's being split into 2 at where it's being split.
So the tracker index is equal to the middle index?
For the first time it goes through, and only if our target number is greater than the number at the middle index. So our tracker number is 7. The value, whatever this is, 7 will be greater than the value at our middle index, which is here, which would be like literally right here. So then we want to add our middle index to our tracker index, because we're looking at the right side of our, on the right side of our arrays, because it's larger. So we want to keep on incrementing. If our tracker, or if our number was like right here, if this was our target number, we'd be looking in the lower half, or the left half of our array, and we wouldn't be adding anything to our tracker index, because our tracker index would still be 0. Because 2, our target number, is smaller than the value at our middle index. So yeah. Let's jump into the actual code. All right, so right here, and my pseudo code, I can always adjust this if I'm missing something. This is just to get an idea of how to solve it. Like I can add values, I can add variables that I might need if I'm missing anything. So our first thing is create a method called binary search that takes in, let's call it target number.
It's 10:30.
It is 10:30. Array to, yeah, let's just say like, yeah, array to search through, or array to search. This is our sorted array, and then our tracker index. And let's assign that initial value to 0. Next, we need to find the middle index and round down if necessary. So let's create a new variable, middle index.
You have an extra comma on 27 after.
Thank you. Middle index equals, how do we find the middle index of an array? So we can find the length of the array, divide it by 2, and round down. So we can do like the length of array to search through, and use the double / to round down for the floor. And now we need to find the middle number. So it looks like here, sorted array. Okay, so it actually creates another variable called like middle number. And we can say array to search, and pass in the middle index to get our middle number. And I forgot to put like, if the number is equal to the middle value, then your target is found. So if it's super easy, I can say just like if target number equals the middle number, then I've already found it. And I can just return the middle. Yeah, so I guess what I did not do in here is use this first one, if. So that's our first if case. So that's if number, middle number, there we go. The middle index. So we want to return the middle index plus our tracker index, because we'll want to keep track of this index and keep on adding it. Or if our middle index or if our number equals, or if our tracker number equals the middle number, say when we're down to here. So for example, if we're going through using this as an example, so tracker index 0, tracker index would then be 1, or I guess would be 5. And then it would break this down even further, where it would just look at this one, and then we'd find it. And then our tracker index would be 5. So elif, we could do an edge case if the length of the array is array to search through is less than or equal to 1. Whoop. We can return -1. So once we get it all down, so if our length of our index is 0 or 1, that means we haven't found it yet. But if it is 1, we would have already found it and returned our answer. And now in here, this is where these next if statements are where the logic. So if the target number is greater than the middle number, we can return. So what do we have to return? The right array. So how do I just grab like right array? How do I split this array to search through and only grab the right hand side of the array?
Use the colon in
Slicing.
the brackets.
Yep. I heard colon, I heard slicing. Where do I want to slice it at?
From the middle
Middle
number
index.
to the last.
Yep, so I can just do from the middle index. And how do I go all the way in to the end of it? Can I do like length
Just-
of, oh, go ahead.
But just the semicolon that would like indicate to the
Okay.
last of array.
Yep, so this middle index, it says like slice it from here. So whatever value that is, colon. And if you don't include anything after the colon, it just includes every single element after that. All right. And now I want to return, I'm going to, using recursion binary search, I'm going to pass in my target number again. I'm going to pass in the right array, and I'm going to pass in the tracker index plus the middle index. And I can even make this a little, I don't need this right array here. I can literally just put that in there and get rid of that. And then else, well, I guess I'm going to do elif target number is less than middle num. It's less than it. I pretty much do the same thing, but instead of middle index to the end of the array, I'll use from the very beginning of the array towards the middle index. And again, if you're slicing on the right-hand side, this part, this is exclusive. So it's not including the value at this, yeah, it's not including the value at this index. And then here we can just include, instead of adding the middle index, we can just return just the tracker index. And let's see if this works. Do I have any?
You got middle index instead of middle num in your elif, the last elif statement at the top.
Oh, thank you. That would have been bad. So I've got this new array. I'm going to call binary search. I'm going to print binary search. I'm going to pass in this new array and execute it.
You need a target number?
Oh yeah, thank you. So I'll also need, what do you want to do, 7? And tracker index. Index equals 0. So the answer should be 0, 1, 2, 3, 4, 5, 6. Right? 0, 1, 2, 3, 4, 5, 6. So it should return 6 if I've done everything right. All right, it's Python binary search. There we go. If we do 9. There we go, 8. So if we do 4. Okay, 0, 1, 2, 3. Can even try like an even larger array. I actually don't know, very large. Yep.
Before you go further, actually, you said tracker index to 0, but then I don't see how tracker index is manipulated or how
So we initially set
changes.
why it changes.
Yes.
So for example, let's look at.
Because I don't see any formulas. I don't see tracker underscore index equal the index of a number or
Right. So
the right or left branch.
we're manipulating the tracker index inside when the target number is greater than the very middle number. So when we return it here, we're taking tracker index, which is initially 0, and then we're adding the middle index. So for example, what is the middle index of this? 4, 0, 1, 2, 3, 4. So I think it would be, yeah, 4. So the middle index would be 0, 1, 2, 3 right there. Or yeah, 0. Yeah, whatever this one, it would be like 3, right?
Okay.
0, 1, 2, 3. And so say our target number is 7. Our target number is 7. We get our middle index. This value would be initially 3. And now we come down here is our target number, which is it's 7, is greater than the middle number. So the middle number is 4. Right? So 7 is greater than 4. So 7 is greater than our 4. We're passing in target number, array to search through. So we're only passing in this half of the array right here. And then we're taking our tracker index, which is initially 0, and adding 4 to it. So we're passing.
Oh, okay.
Right
So
there. So I can say like new tracker IDX equals tracker IDX plus middle index. And now I can just literally, instead of doing that there, I can put that in there.
okay. Thank you.
Yep.
What about the sorting function when you have an unsorted array?
Then you would just sort the array up here, like sorted array, but I think yeah, so you just, so if you're searching through, find the middle values, sorted values, so are given the parameters of the problem, assume that the array that's being passed in is sorted, but you would just array to search through. I don't even know what it is. Is it sort? Something like that. So you would just sort the array before you would do any of this.
Okay,